Section 9.2, Estimating a Population Mean. By the end of this lesson, you will be able to obtain a point estimate for the population mean, state properties of the student's t-distribution, determine t-values, construct and interpret a confidence interval for a population mean, and determine the sample size necessary for estimating a population mean within a given margin of error. For Objective 1, we want to obtain a point estimate for the population mean. Remember, the goal of the statistical inference is to use information obtained from a sample and generalize the results to the population being studied. As with estimating the population proportion, the first step is to obtain a point estimate of the parameter. The point estimate of the population mean, mu, is the sample mean, x bar. Now, for example, computing a point estimate of the population mean. Now, the website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in the table below show the reported miles per gallon of 2011 Ford Focus automobiles for 16 different owners. We want to obtain a point estimate of the population mean, miles per gallon, of a 2011 Ford Focus. Now, the sample mean, doing it by hand, would be the following. We would take all these values and divide it by how many values there are, which is 16. Now, in this case, when we're given a numerous amount of values, now we can just use StatCrunch. So what are we going to do? We're going to come in here. We're going to list in all our values into StatCrunch. We're going to come in here, select Stat, go to Summary Stat, and select Columns. Make sure we select the column for miles per gallon, and then we want the mean, and then select Compute. Okay, and so therefore, I'm going to go ahead and copy this. So we're going to get the mean to be 36.8. And so therefore, that means that if we did this by hand, 588.8 divided by 16, which gives us 36.8 miles per gallon. So the point estimate, x bar, of the population mean is 36.8 miles per gallon. And remember to round statistics to one more decimal point than the raw data if necessary. Well, in this case here, the raw data was 1 decimal point, and when we did our division, it only gave us to 1 decimal point. Now, if it would have been a further decimal point, then we would have included that for that point estimate.